Algebra 1 students, in this video today we are going to look at solving linear equations. Okay, solving linear equations. We will be starting off with easy equations, obviously, and then we're going to work up to the harder ones as the chapter progresses. Now, hold on one second here. Make sure this is turned on. Okay, here we go. Now, your heading for today, and please copy this in your notes. Grab your pens or pencils and copy this down. Solving linear equations. Please write that in your notes. Lesson 3.1. Copy that in your notes, and then be sure and put today's date so that your notes are organized. Okay? Please copy all of that down. All right, let's move on. Now, most of you will find today's material pretty easy, and that's encouraging to me, but it's also discouraging because as the equations become more and more difficult, students sometimes give up or get a little frustrated. There's really no need for that, okay? They're easy today, solving linear equations. And if you will stay up on the new material as we add more and more difficult equations, they will continue to be easy. Solving linear equations is not a difficult thing as long as you stay on top of your work and use the steps that I give you. Now, I will be giving you steps today. Do you understand? That will help you solve these linear equations that we will be looking at. Understand though, listen carefully, as we progress to harder equations, I will be adding to these steps, okay? Until we finally, at the end, have a complete list of steps that will help you solve linear equations. I don't have the book open here in front of me. I'm not sure how many lessons we're going to look at in which we're solving linear equations, but I know it's going to be probably about 4 or 5 lessons. It's going to be a lot of lessons, and as they become more and more difficult, I'm going to have to add more and more steps. Like, for example, today we're just going to have 2 steps and that's it. 2 steps and nothing else. Okay. Well, as these as the equations become more and more difficult, obviously we're going to have more steps. Okay. Now today we only need 2 steps, like I just said, to solve the equations that we will be looking at. So here are the steps. Please copy these down. Simplify both sides of the equations as far as you can. This should be singular. Simplify both sides of the equation as far as you can. Isolate the variable, or in other words, get the variable all by itself. That's it. That's all you have to do today. Nothing more, nothing less. Okay? So I'm going to move on. If you want to pause the video and copy these 2 steps down, fine. If you've already copied them down, no problem. But I do want you to write these 2 steps in your notes. Now, before we get into solving some of these problems, I want to show you what a linear equation looks like. Now, you do not necessarily have to copy these examples down. That's up to you, okay? You can if you want to. This would be an example of a linear equation. Now, they can get a lot harder than that, but there's a linear equation. Now, first of all, notice for you to have a linear equation, you must have an equal sign. I know that's pretty obvious, but let's be honest. Let's make sure everyone understands this, okay? In order for you to have a linear equation, you must have an equal sign somewhere. This is not an equation. That is an algebraic expression, but it's not an equation, okay? Because there's no equal sign anywhere, okay? But here we have an equation. This is an equation. Now, in algebra, we study linear equations. Are you listening to me, guys? Listen carefully. Quadratic equations, cubic equations, quartic, Q-U-A-R-T-I-C, quartic equations. You do not have to write this down. Just listen. We solve absolute value equations, exponential equations, that's more algebra 2, logarithmic equations, and so on and so forth. You get the idea. So it's very important that I teach you what a linear equation looks like. If I don't show you that, then you don't know the difference between a linear equation, a quadratic equation, so on and so forth. So, a linear equation is when your variable, all of your variables have is 5, 3 to the 1 power is 3, 4 to the 1 power is 4, and x to the 1 power is x. X to the 1 power is 1. X, excuse me. So that's basically it. In order for you to have a linear equation, you must have an equal sign, and all of your variables must have a power of 1. If you have a 2 right here, this would not be a linear equation, okay? This would not be a linear equation. All of your variables must have a power of 1. So if there's no number there, you can put a 1 in, the same thing, okay? That's a linear equation. So I hope that makes sense. You need to know that, okay? So if I rambled a little bit there, I'm sorry. If you want to take notes on that, that's up to you, but that is what you need for a linear equation. Now, this video is not going to be that long today. Let's try solving some of these equations, okay? So here we go. Let's take a look at our first problem here. The first problem we're going to look at today is x negative 5 equals negative 13, okay? Now, look at your notes. Step 1 says simplify each side as far as you can. Now let's talk about what I mean by the word side. It's very important you understand this, okay? This is called my left side. Here's your equal sign. That's what divides the equation into sides. Over here is my right side. So from now on, when I talk about sides of an equation, I'm talking about to the right of the equal sign is one side, and to the left of the equal sign is another side. Got it? Okay. Now, step 1. Simplify each side as far as you can go. So look at the left side first. X negative 5. Now guys, I hope you remember by now that you cannot simplify that. You cannot. I hope we know that by now. If not, I'm going to be really discouraged. These two terms are called unlike terms. They're unlike. This is called an x term. This is called a constant term. Now, if I had x times 5, no problem. You can do that. You can multiply unlike terms. X times 5 is 5x, no problem. But you cannot combine or add and subtract unlike terms. You cannot do it. So there's nothing I can do to this side over here. How about this side? Nope, nothing I can do. Negative 13. How are you going to simplify negative 13? So step 1 is done. Now look at step 2. Get the variable all by itself, or in other words, isolate the variable. Okay? Well, here's how we do that. Are you ready? Take great notes and pay attention. We move terms. Now don't panic. Listen to me. It's so easy. Oh, by the way, let me stop and say this right now. From now on, you've got to show your work when you're solving equations. I will not give you any credit on tests or quizzes if you do not show your work. I will not give you any credit. Alright? I will not give you any credit if you don't show your work on equations. I know you can do this in your head. I know that you know the answer is negative 8 because negative 8, negative 5. You owe me $8, you owe me 5 more. Negative 8, negative 5 equals negative 13. But we're going to get into hard equations where you will not be able to do them in your head. And so you must show your work on your homework, and you really need to show work in your notes too. So I want to get x by itself, so we're going to move terms around. In other words, I have two terms. I remember I taught you earlier in chapter 2. Positives and negative make terms. Okay, so here's the negative sign. I have one term, I have another term, I have two terms. So if I want to get x by itself, isn't that what step 2 says to do? Isolate the variable, or in other words, get the variable all by itself. If I'm trying to get x all by itself, then take this negative 5, bring it to the other side, and when you do, you change the sign. That would make a great sentence to write in your notes. Please write this in your notes, would you? Write this in your notes now, please. When a term switches sides, its sign must change. Write that in your notes, please. I'm going to pause a second while you copy that in your notes. When a term switches sides, should be an us there, its sign must change. Let me say that again. When a term switches sides, its sign must change. Now I'm going to erase this, so if you're not done, pause the video, okay? So when I brought this term over, I switched sides. It was a -5. I made it a +5. So now think about it. Bring down your equal sign. If I got rid of this term, what am I left with? X. Let's combine these two over here. You owe me $13. You pay off 5, and you still owe me 8 more. So there's your answer. How do I know I'm finished? Because the X is all by itself. When the variable, whether it's X or N or A, it doesn't matter what the variable is, okay? Whenever the variable is all by itself, or we call that being isolated. When the variable is isolated, then we know we're finished. So there's your answer. And we did that in 2 steps, guys. 2 steps. Step 1, simplify both sides of the equation as far as you can. Step 2, isolate the variable, or in other words, get it by itself. So the answer is x equals -8. Got it? X equals -8. Now, let's put that in for x. Let's check our answer. For x right here, I'm going to put a -8. So I have a -8 and a -5. Now these two are not multiplying. A lot of students see these parentheses here, they think they're multiplying. No, no, no. This would be multiplying. Because there, the 5 is right next to the parentheses with nothing in between it. Or this would be multiplying. That would be multiplying 2 parentheses side by side, but here, in between the parentheses and the 5 is a negative sign. Okay, they are not multiplying. Alright. So I have a -8 and a -5. You owe me $8. You owe me 5 more. Now you owe me -13. And look at that, I get a true statement. So my answer is correct. You can always check your answers on these, okay? Alright. Let's solve this equation. You're welcome to work ahead or stay with me. It's up to you, okay? Now, step 1, we're going to simplify each side. Now, on the left side over here, I'll put an L for the left side. There's nothing I can do with the -8, nothing at all. On the right side, there is some simplification I can do. I definitely cannot combine these two terms. I cannot. They are unlike. However, notice your 4 has that double sign thing. We can simplify that. We don't want a double sign. We've talked about this. Whenever a number has 2 signs, if the signs are the same, negative, or positive, then the number becomes positive. So my -4 is really a +4. If it would have been positive, then I would have a +4. If the signs are different, like positive, then I would have a -4. Or if it was positive, negative, I would have a -4. But I do not. I have a negative. The signs are the same. So 4 becomes positive. See, listen to me, guys. If you would have started trying to move terms around before you simplify, you have a mess. You would have a mess on your hands. Always simplify both sides of the equation as far as you can first. Always do that first, okay? So, can I simplify this? No. Can I simplify this any further? No. They are unlike terms. No. So on to my last step. Get the variable by itself. Well, if I want to get n by itself, I must get rid of this +4. So take this +4 and move it over to the other side. And when you move something, when a term switches sides, you must change the sign. So this +4 becomes -4. Bring down your equal sign. Over here I'm left with n. Here you owe me 8, you owe me 4 more, so now you owe me 12. So your answer is -12. Now, let's see if that's right. Let's check our answer. Where the n is, we're going to put -12. So -8 equals, here's my n parentheses, -12. $8, you pay off 4, you still owe me negative 8. Check. So remember, this is not your answer here. That's not your answer. I'm just checking my answer. My answer is negative 12. Okay? Let's try another one and see how you guys do. You can work ahead if you want to. No problem with that. Okay, step 1, simplify both sides of the equation. Now, obviously, on the right side over here, I cannot simplify just a negative 3. However, on the left side, I can do some simplifying. The absolute value of negative 8 is positive 8, and then bring down your positive x. Now, if you want to put a positive sign here, you can. You really don't need to, because you guys know by now, when there's no sign at all, it's understood to be positive. But the absolute value of negative 8 is 8. What's the absolute value of positive 8? Is it negative 8? No, the absolute value of positive 8 is 8. The absolute value of negative 8 is 8. Absolute value just simply means to make the number positive. So now I have completely finished step 1. I have simplified this side as far as I can. And I have simplified this side as far as I can. There's nothing else I can do. So on to step 2. Get the variable all by itself. So get x all by itself. Okay? So here we go. I don't want this positive 8 here. I'm going to bring it over and make it a negative 8. So bring down your x. Negative 3, negative 8 is negative 11. So I'm claiming this is my answer right here, okay? Negative 11. Let's check it and see if we're right. So where the x is, we're going to put negative 11. So the absolute value of negative 8 plus, and in parentheses for x, negative 11 equals negative 3. Okay? Now let's simplify this over here. First of all, the absolute value of negative 8 is positive 8. And now I've taught you when a number has 2 signs. Look at the 2 signs. If they're different, then the number is going to be negative. If these 2 signs are the same, then your number will be positive. So the signs are different, so we put a negative sign. Then bring down our 11. Now, positive 8, negative 11, you have $8, you owe me 11, you pay off 8, you still owe me 3 more. So negative 3 equals negative 3. It checks. So this is the correct answer. Okay, students, one more problem and we're done with the video, okay? So here we go. Okay, let's relax and use our steps. Step 1, simplify both sides. Well, obviously there's nothing I can do to a negative 3. Over here, though, I do have a double sign, so I can simplify a little bit. I have a 4, that's 2 signs. They're different, positive, negative. They're different. That means to make the number negative. So a negative 4. Now here's where it gets tricky, okay? Is step 1 completed? Have I simplified both sides as far as I can? The answer is yes. I cannot combine these 2 terms. They are unlike terms. And I can't simplify a negative 3. So I have simplified as far as I can go. Got it? Well, then step 2 says to get the variable all by itself. So if I want to get a by itself, I've got to bring this negative 4 over and make it a positive 4. Got it? So now I'm left with negative a equals positive 1. Okay? Now, here's where it gets a little tricky. Alright? And there's another way to do this I'm going to show you in a second. But first of all, please notice I'm left with negative a equals 1. Now I wish I was left with a equals negative 1. You know what I mean? But I'm not. So I'm left with a negative a equals 1. Okay? So here's what you can do. You can say to yourself, if negative a equals 1, then a equals negative 1. In other words, you can change this sign over here. As long as you change this sign over here, that's totally legal. So if I had negative x equals negative 10, I can change x to positive as long as I change the sign of this number over here too. Okay? So that's one way to look at this. That's one way to look at these problems, alright? So if I have negative a equals equals 1. Then I can change the signs of both sides and say a equals negative 1. That's fine. That's one way to do it. Another way to do it is simply this. Think about it. You could bring the negative a over here and make it a positive a. This is a little confusing. I don't recommend it. You know what? I'm not going to show you this. This is going to be too confusing, so I'm not even going to show you. So back to what I had before. Bring the negative 4 over like I taught you. Make it a positive 4. And you're left with negative a equals 1. Well, a is not isolated really because you still got a negative sign here, so you can change the sign of this. As long as you change the sign of this. And there you go. A equals negative 1. Now, let's check our answer. Okay, let's see how we did on this. Here's a. Notice I've got a negative sign right here. So it's negative sign, parentheses, negative 1. Then bring down your positive negative 4. And all of that equals negative 3. Now let's simplify. The 1 has two signs, negative, negative, so I'm going to make it a positive 1. The 4 has two signs, positive, negative. Signs are different, so I'm going to make it a negative 4. It looks like it works. A positive 1, then a negative 4, so negative 3. Negative 3 equals negative 3. Check. So this is the correct answer. Alright, that is the correct answer. Okay. Moving on to one more problem here, and we will be finished. Okay, here we go. Now, first of all, we're going to simplify both sides. Obviously, there's nothing I can do with a negative 3 here. And actually, we've done this one already, haven't we? Okay, guys, that's embarrassing. Alright, so there we go. That should be it, guys. Okay, so I really hope this video has made sense to you. I hope it's been a help to you. Okay, we're going to get into a lot more difficult equations than these. Alright, but for now we're starting off easy. So we just have two steps. Simplify both sides of the equation and then get the variable by itself. Alright.